Hello, this is a presentation on setup and preparation work for DPA attack on Sasebo-w. DPA here stands for Differential Power Attack. Before exploring the topic, we'd like to see why this project is important. In our daily life, we all use multiple kinds of smart cards, SIM card, ATM card, cash card, etc. These cards can be used to store and exchange information securely. However, by sampling power trace of our system multiple times, attackers could be able to analyze data and reveal secret key of smart cards. Thus, Sasebo-w was implemented. It supports both breaking of smart cards and implementing of customized or protected software. With this board, researchers can develop safer algorithms for card and prove by attacking it. Or rather, they can attack available implementation to point out problems for existing systems. In this world, attackers and protectors work together as a team to make smart cards safer. There are setup steps before using the system. First, structure of Sasebo-w. It consists of 4 systems. One is a card, one is power measurement point, one is communication protocol between the system and PC, and one is FPGA. While FPGA, well, it was sweet if software implementation was sufficient, but attackers could be able to get information before the information went into the card. Thus, FPGA makes it possible for IC designers to protect the system from hardware point of view. As we are mainly doing software implementation and protection, we are only burning provided FPGA ROM and EEPROM for APDU. APDU stands for Application Protocol Data Unit. It defines command for all commercial cryptographic algorithms, like setting the key, receiving ciphertext, etc. Then we are burning unprotected AES algorithm into the card for our first setup. For scope, we need to make sure that the bandwidth was at least 10 GHz and we are using a differential probe with 50 ohm resistance. As mentioned, our implementation was software implementation, and we definitely need a tagging environment, which requires a sampling software on PC and analyzing software on either PC or server. We are implementing these two by ourselves. Requirement for sampling software is to send plain text, receive ciphertext, and record multiple traces from the scope in one run. To do this, we need to understand specific commands in APDU and driver for scopes UART or network. Here is one of our sample trace to show successful implementation of sampling software. Next up, attack. For 1 byte, we have 256 possible keys for each byte to guess. With knowledge of algorithm, we got 256 hypothesis intermediate values after S-box. After applying a power model, we could guess power these hypothesis intermediate values consume. If we do a correlation between this power and actual power, we could guess the one with the most correlation shows the secret key for this byte. We could see here that peaks of correlation for 16 bytes occur in sequence of 0, 4, 8, 12, 2, 5, 9, 13, etc. Compared to given cut source code, we could prove that our attack software was correct. Then it came to choice of power model for mapping hypothesis values to hypothesis power. Bit model focuses on dependency of certain bit value on power consumption. This model was bad during strong data dependency situations, such as 01 and 00 for 1 byte. However, when power depends more on one bit and less than another, this model may not work well. Hamming weight model focuses on Hamming weight of value on power, which should describe model of power better as it equally considers all bits' contribution to power consumption. However, when situation came that number of ones and zeros are equally distributed, this has problem. Hamming distance model similar to that of Hamming weight model, but it considers the data change or switching power consumption. However, information on data before it's switched is important. We take plain text here to test this model. We could see the effects of this power model. X-axis is the number of power traces sampled and Y-axis is correlation. The black line represents the correct key. We could see the Hamming weight model performed better than bit model as predicted. Over here, Hamming distance model did not create more correlation than Hamming weight model with plain text, and this should prove that our information was wrong. In conclusion, in our later tests, we should not use and not to expect attackers to use Hamming distance model to attack due to general lack of knowledge on device. We are mainly using Hamming weight model to conduct attack and prove implementation. Protection should focus more on intermediate values as they are only information for attackers to get the key. This may also lead to decision for our next step, implementation of mask AES.